This is assignment 19. We're on page 2. Today we'll be looking at absolute value functions. Every absolute value function either has a V shape, and I remember that, V for value, or it could be upside down. Either that way, upside down, or some piece of that. So exercise number 2, that's because we're on page 2. Answer the following questions based on the graph y equals absolute value of x. So what I did ahead of time is I went to my Desmos graphing calculator, and you can see I typed in absolute value of x. So to get those vertical lines on the keyboard, it is Shift, and then 2 spaces up, you'll actually see a vertical line. You can use those and it will do that for you. So I'm going to go to my table, click on my gear, oops, hit the, now ours goes to -3, so I'm just going to throw that in down here, -3. So we already have -2, -1, 0, 1, 2, and 3. So we're going to copy those values carefully into this table here. So this is 3. Remember, the absolute value symbol just turns any number into a positive number. So if we answer the questions where we evaluate, remember, when there's a parentheses, that means x. So when x is 2, y is 2. Now this isn't on our table, but you can probably figure it out. When x is 7, y is 7. When x is 0, y is 0. When x is -7, you can look that up on the table, or just think about it. Y is 7. Now we're going to plot our points. And I'm going to draw this with arrows like that. If you have a ruler or back of a magazine or something, or an index card, it'd be nice if you could draw a straight line. So now it says for number, well, there is no number. When does f of x equal 3? Remember, that's your y value. So here's a 3. This is -3, 3. And here's a 3. This is 3, 3. So you could write this 2 ways. You could write your points, -3, 3. Lots of 3's going on here. Or you could just say x equals, and you could say what your x numbers are, -3 and 3. What is the y-intercept? That's where this graph crosses the y-axis, right here, y equals 0. And actually, the x-intercept is the same, because this is the point 0, 0. X equals 0. A lot of these numbers will kind of match up and be duplicates. The very lowest value, remember when they say value, they want the, oops, not lowest, the highest y value. We've got arrows. Arrows mean infinity. They go on forever, to infinity and beyond. So we would just say infinity. The very lowest value is right here, this point right here, y equals 0. It doesn't go below that. Now this says for what interval is the graph increasing? So sorry, I keep going up and down on this. So let me use some green here. So from here all the way like this, it's increasing. And remember, when you give intervals, you use your x number. So from 0 to infinity. Always do your smallest number on the left, biggest number on the right. So 0, we colored in that square. Now infinity is round. You can never color in the point infinity. Now for decreasing, let's do some orange. A little orange action going, oops. So from here, all the way down. Remember, you read a graph from left to right. So here we're going from -infinity to 0. -infinity to 0. We color in 0, -infinity is round. What's the average rate of change? Remember, that means slope. This thing is not going away, unfortunately. So I'm not going to keep going back up and down. Please just look at your graph. Find the points when x is -3. Oops. Shoot, it's going to go back to the regular color. And when x is 0, find those 2 points. So I got -3, 3 and 0, 0. Now the formula for slope, again, it's not changing. Y2 minus y1 over x2 minus x1. I'm going to label, this is the point x1 and y1. This is my second point, x2 and y2, and I'm going to plug them in. 0 minus 3 over 0 minus x1 is -3. When you put that in your calculator, you actually get -1. Now the next problem, what is the slope from the interval 0 to 3? That's asking you the exact same thing. I just put it in different notation. So our point is 0, 0, and the x value is 3, 3. Try to plug that into your slope formula and see if your answer matches mine. So we do y2 minus y1 over x2 minus x1, and you end up with a 1. Last section here, I'm just going to draw the picture again so it looks like that. How can you tell it's a function? Quickest way, passes the vertical line test. Remember, wherever that vertical line goes, the graph only crosses it one time. So I'm just going to say it passes the vertical line test. And I have a typo for the last one. How can you tell this is, it shouldn't be linear, I did copy and paste, absolute value function. So using the picture, it's a V shape. That's the quickest way. Now, if we look at the numbers, that means the table. Because sometimes on a Regents exam, they won't give you a picture. They won't give you a graph, they'll just give you tables. Without having this picture at all, just looking at the table over here, you can tell this is an absolute value. Here, if you look, it's going down at the same rate. It's going down -1, -1, going down by 1. Then all of a sudden it switches direction. And now it's going up. But it's going up at the same rate. So it makes down, up. So if it's moving at the same rate, the y values, but it switches direction. So I'm going to say the y values change at the same rate. That means they're going up or down at the same number. And not just that, I'm going to say, and they switch direction. They go from increasing to decreasing or decreasing to increasing. They switch direction. I ran out of space, so I just said direct. So they switch direction. Guys, if you missed class, you're going to put this into your packet and you're going to post a picture onto our assignment. And then you're going to work on your Delta Math assignment that goes with this. Delta Math assignment 19, you're going to practice graphing absolute value functions. Let me know if you have any questions, and good luck. Enjoy. See you soon.